All right, pre-algebra students, we are moving into our new module about writing linear equations. So in this particular lesson, we're going to practice how to apply vocabulary and keywords to write and understand all parts of a linear equation. So first, we're going to take apart our slope-intercept form of the equation y equals mx plus b. We're going to look at some key words that we can use to identify slope and y-intercept, and we're going to interpret real-world situations. So make sure that you have your guided notes out, and let's get started. So first, let's take a look at our equation of a line y equals mx plus b. Now, all four of the variables in this equation mean something different. So the two big variables we use often. One of them is m. M, we know, is slope. So m is the slope. We can also call it the rate of change. We use other formulas for this. We use delta y over delta x, which is just saying change in y over change in x. We know that it represents rise over run of a line on a graph. And we know that we can use slope formula using 2 points on the coordinate plane to find the ratio of slope. Slope is just a ratio of two values and how they relate to each other. Now let's talk about b. b is the y-intercept. And so b, the y-intercept, is kind of like a starting value. We call it the initial value. It's where a line crosses the y-axis. Running out of room here. Where a line crosses the y-axis. Now, we don't really pay a whole lot of attention to x and y in this equation, so let me talk about what they mean. So x and y represent different values. X and y are different variables. They represent different quantities. Usually we write an ordered pair, x, y. And there are infinitely many x, y pairs that satisfy a linear equation. Basically, there are infinitely many points on a line with this format. So let's talk about x first. X is what we call the independent variable. Independent variable. We also call this the input. X is the input in a linear equation. So input, independent variable. It's basically what changes in the equation. When you change x in the equation, you also change y. So let's talk about what y represents. Y in the equation is the dependent variable. Basically, the value of y completely depends on the value of x, which is changing. I know in science class we talk a lot about the independent and dependent variables in an experiment. So it's basically the same thing. X, the input, changes and completely affects the output. So y is output, and we also call it the dependent variable, like so. So now let's provide some context to all this. We're going to be looking for key words in real-world problems and situations, especially regarding slope, which is our m variable, and b, our y-intercept. So when we interpret a word problem and we're looking for the value that matches the slope. We're going to see words like each, every, per. We're going to see the word rate very often. You might see some sort of measurement of time like monthly, daily, yearly. So these are all ways that we can identify slope in a word problem. Y-intercept is a little bit different. The y-intercept, I called it the initial value. So you're going to see something like starts at, starting in general. You might see flat rate or fee. When something's flat, that means that it doesn't change, it's just fixed, meaning it can't really be the slope in the situation. So those are all ways that we represent y-intercept. So now let's take a look at some real world situations using those keywords we identified. So the first one says, Trinity is planning to buy a gym membership at Crunch Fitness. At this gym, the sign-up fee is $40 with an additional cost of $10 per month. So I'm going to go ahead and underline some of the keywords and obviously the quantities that I'm seeing here. So at this gym, the sign-up fee is $40 and an additional cost of $10 per month. We especially want to pay attention to sign up. We want to pay attention to the word per because those are some of the key words we're looking for. So the first question says, what is the slope? Now, slope is a rate. Slope is a rate, and it's one of the things that changes in our equation. Or, I'm sorry, that stays constant in our equation. So this cost of $10 per month, that's a constant thing that is always going to be happening in the equation. The slope is going to be 10. The y-intercept I said was the initial or starting value. So when I see a sign-up fee for a gym, that means we're starting off by paying $40. And that's a flat cost. That isn't going to happen every single month. It's just one-time fee of $40. Y-intercept here would be 40. So knowing that M is 10, B is 40, and we need to put this into the equation y equals mx plus b, we're plugging in the values of m and b, the equation should be y equals 10x plus 40. So the slope in this situation represents the monthly cost. It's the monthly rate. Monthly cost or gym fee. The y-intercept represents the starting value. It basically says that's the sign-up fee. And just so we're clear, so $10 per month for the slope, $40 to sign up. So now let's think about what the independent variable and the dependent variable are. X is the input, Y is the output. So in this equation, Y equals 10x plus 40, we need to decide what the two variables are that we're comparing. What units are we using? So in this problem, I can see dollars and I can see time. I see months. So we need to decide which variable, which unit, dollars or months, is impacting the other. Well, when I think about it, I'm not going to spend any money if I don't, any extra money, I mean, if I don't go to the gym. like, or if time doesn't pass. So my time, my months, number of months is going to represent my independent variable. My input is months. My output is cost. So the cost of the gym completely depends on the number of months I go to the gym. So that's going to be your cost. Let's try another one. So in this problem, Evan gets a gift card for his birthday that has $50 on it. He uses it to purchase a bag of Takis from the dollar store every day after school. So I see some identifying information here. Evan gets a gift card for his birthday that has $50 on it. He uses it to purchase a bag of Takis from the dollar store. I see that keyword every day. And I don't see any other numbers in this problem, but I notice that he's going to the dollar store. And everything at the dollar store is $1. So I'm going to write myself a little note here, $1 per bag. So that's some identifying information. Let's also, while we're at it, look at the units we're using. So I know that we're using dollars for sure. And it looks like the other unit we're using is the number of days. So those are the things that are changing in this situation. So the slope, I identify the slope by finding the each, every, per, or something to signify rates. So every day. So he buys one bag every day after school. So he has a gift card and he's spending money. When you spend money on a gift card, your balance decreases. So I'm going to say that the slope is -1, -$1 per day. The y-intercept is the starting point. This gift card that was purchased for him has a starting value of $50. That's the y-intercept. The equation then, if I write it, y equals slope times x plus y-intercept, well, slope is -1, y-intercept is +50. So we start at $50, we spend 1 every day. So the slope represents the every day, or I'm sorry, every dollar. So we're looking at dollars per day we're spending. Dollars per day spent on Takis. The y-intercept is your starting amount of money. So $50 on gift card at the beginning. So now let's take a look at these variables. The x variable, the input, basically it's the number of days. Usually the input is time. So we're going to say the input is the number of days that he goes to get a bag from the dollar store. And y represents not just the cost, it's the amount of money left on the card. Money left on card. Because let's say you start out with $50, he goes to the dollar store to get a bag 2 days this week. Well, he spent $2. The remaining balance, y, would equal 48. For additional practice with problems like these, try out numbers 3 and 4. All right, so that was our lesson. Thank you so much for watching. Make sure you try out the additional practice problems and check your answers with my filled in notes, and ask for support if you need it. Have a great day.